Hello guys again. So we have discussed the glycogenesis. Now we have to discuss the glycogenesis, that is the reverse process, the formation of glycogen. So what we're gonna need to form glycogen. So basically we have four important molecules. The first one is the UDP glucose, the glucogen synthase, glycogenin, and the branching enzyme. These are the four essential molecules to form the glycogen. So we're gonna start by here. The start point of this synthesis of glycogen is G6P, glucose 6-phosphate. As you can see here, we have the formation of G1P to form G6P. As you can see, that is the reversible reaction for the glucogenolysis. We have to form G1P by G6P. So this is like a summary here. Glucose, we're gonna have glucose by the glycogenolysis. We're gonna form glucose 6-phosphate by the action of glucokinase, liver glucokinase, and we're gonna form the G1P. Once we have that molecule, we have to use nucleotide sugar, the UTP. Why we do this? Look at here, sugar nucleotides. They're gonna activate that molecule, inducing to nucleophilic attack to the molecule. So this UDP glucose molecule is gonna be more susceptible to nucleophilic attack and for apolymerization of the molecule. Okay, we're gonna go here, down to cyanamation. This is the same that we discussed here. We have to form glucose 1-phosphate to add the portion of the nucleotide sugar, the UTP, to form a UDP glucose molecule. This is not important. This is the synthesis of the nucleotide, but this is not of our interest here. This is what we're gonna have. We have here a portion of glycogen. So how is gonna be polymerized, this molecule? By the action of glycogen synthase. This enzyme here. Glycogen synthase is gonna catalyze the formation of the chain, the polymerization. Here we have the action of glucogen synthase and the liberation of UDP, because we have the UDP glucose here. This is the portion that's gonna be released. So we have the linkage here, an alpha 1,4 linkage, glucosidic, and we're gonna read here glycogen synthesis. A glycogen chain is elongated by glycogen synthase. The enzyme transfers the glucose residue, UDP glucose, to the non-reducing end of the glycogen branch. Basically what we discussed here. And the branch here, branch synthesis of glycogen, the glycogen branching enzyme. This is another enzyme that it's implicated, as we discussed. It has two activities like the other enzyme of the glycogenesis. It has the trans-glycosylase and glycosyl transferase. So gonna be here. We have the linear molecule of glycogen. This portion of here is gonna be in the branch with the linkage 1 to 6, and this portion is gonna remain in the same place. It's a very similar process like the glycogenolysis, but we can't polymerize this molecule if we don't have an initial portion of glycogen. So what we gonna do with that? So this is we have to make, like the DNA, we have to make primers to add the other, to initiate the polymerization. This is the glycogen action here to make primers for the glycogen polymerization. Glycogen synthase cannot initiate a new glycogen chain de novo. It requires a primer, usually preformed polyglucose chain or branching having at least 8 glucose residues. That it's very important to remember. Glycogenin is gonna synthesize a glycogen chains de novo, but in the 8 glucose residues synthesized by these enzymes, this glycogenin is gonna be separated from the molecule to initiate another primer. So we're gonna see this image here. As you can see, we have the glycogenin in this portion. Glycogenin has a tyrosine residue in the position 194, and this portion of glycogenin is gonna have a nucleophilic attack to the UDP glucose. This is the way that it's gonna be elongated to the 8 residues that we discussed a minute before. As you can see, the chain is gonna be elongated by the UDP glucose monomeric fragments, and then we have 2 residues here. We're gonna add 6 more to have the 8 residues, and then the glycogenin is gonna be separated from this fragment, and the synthesis of glycogen by the glycogen synthase is gonna be initiated to form the branches and the transference of fragments, etc. Basically, that it's the glycogen synthesis. Thank you.